Hi guys, let's talk about inclined plane. So far, we discussed a simple case, that is, if a block is rest on a table surface. Since it is rest, so on this block forces are acting, equal forces are acting, so that's the reason the block is not moving. If weight is acting downward, which represented mg, and there is an upward force which balances the weight, so this upward force, which is known as normal reaction force R. So this is a flat surface, table is a flat surface. But today's concept I would like to discuss about inclined plane. So what is the inclined plane? Inclined plane means a surface which makes an angle. Suppose if that surface with tilted like this angle, if it is tilted with an angle, so this tilted angle with respect to base, suppose just like this. Now here we got an angle theta. Now this plane is making an angle theta with the horizontal. Now this plane we call as inclined plane. So if we keep objects in an inclined plane, suppose if I keep objects in an inclined plane, so the objects will slide. So if you can keep the objects in an inclined plane, so it depends upon the angle, what happens? The object starts to slide. So before this is the condition R and mg. Now how do we draw the R and mg for an inclined plane? Suppose for an inclined plane, if I take, this is an inclined plane which is making an angle with the horizontal. This is making an angle theta with the horizontal. If I take a block of mass m which kept on inclined plane, and here be careful because the block is now making an angle theta with the horizontal. Now the block is at rest. It means the block is not moving, it is at rest. At rest. If the block is at rest, so how the forces we can represent? As usual, we represent that normal reaction force R, which is upward direction, and to balance the normal reaction force, and we are having weight. Now the weight will be acts exactly the downward direction in this direction. Now it is not exactly the same in the above the case. Suppose if I take a coordinate axis at there. Suppose if I draw a coordinate axis with the green color, I am drawing coordinate axis at here. So let it be y-axis. And if I take, this as an x-axis. Now normal reaction force as usual representing positive y-axis, but the mg is making an angle theta, with the horizontal. Now if this is mg, if making an angle theta, now we need to split the components of mg. Mg component goes to along this side mg cos theta, which is horizontal component, which makes an angle theta, and opposite component this side it goes to mg sine theta. Okay, as per I said, the block is at rest. If the block is at rest means some of the forces which are acting should be equal. Now in this case, the normal action force R which equal to mg cos theta, one of the component, it means one of the part, one small portion, and another component, the mg sin theta component, which equal to, here we need to consider one more friction force which is acting opposite direction, so that is friction F suffix k. Since it is not moving, so we can consider this as limiting friction max, Fs max. So now the normal action force which equal to mg cos theta and Fs max, which is known as the coefficient of limiting friction, which equal to mg sin theta. So this is how the mg component splits into two components, mg cos theta, mg sin theta. It is only happens in inclined planes. It only happens in inclined planes. But when it comes to ordinary surface and all, so in this case R equal to mg directly. So there is no division of the components when object is horizontally rest on a surface. But when it comes to inclined planes, because of that angle, so the component of mg, the mg is resolved into two components, mg cos theta and mg sin theta. So I got the two equations. Let me divide 2 upon 1. If you divide the second equation upon first equation, that equal to mg sin theta upon mg cos theta, which equal to Fs suffix max upon R. So let us cut the like terms. So if I eliminate the like terms mg on both sides, so here I can get tan theta. Tan theta equal to Fs max upon R. Okay, in the previous concept, if you remember, Fs max upon R, which also known as mu s. So Fs max, which also known as mu s. Therefore, the tan theta equal to mu s. So don't be confused here, the theta what we considered. Okay, so here the angle theta having a special name, this particular angle theta, the angle made by the horizontal plane with the angle made by the inclined plane with the horizontal. So this angle, which is known as angle of repose, angle of repose, REPOSE, the angle made by the inclined plane with the horizontal, which is known as angle of repose. So from the angle of repose also we calculate the coefficient of static friction, mu s. So here the theta, we define that, so that what we need, very important. The definition of angle of repose, it is the minimum angle, that an inclined plane, makes with the horizontal, when a body placed when a body placed on it and just begins to slide down. So that minimum angle we call as angle of repose. So this angle of repose is used in inclined planes, and the same angle, so we call as angle of friction. So that we use in when object is at horizontal. So this angle we call as angle of friction. The same angle of friction will changes to angle of repose when it comes to inclined plane. So in inclined plane, the very important thing you need to understand that if an object is making an angle theta, if that is a line, it is making an angle theta with the horizontal. So this theta, which is known as angle of repose. Or if you measure the same, if this is a block, if it is at rest condition, it is at rest. If it is at rest, the sum of the forces which are acting on the block should be equal. So this is normal reaction force. Remember, normal reaction force is always perpendicular to the surface. It do not change the angle. But in this inclined plane case, the weight mg will makes an angle. So this is weight mg, it gets tilted. Now that weight makes an angle of the component. If I can take the coordinate axis right at here, and one more coordinate axis I can take, that is the positive x-axis and negative x-axis. And so the very important thing here, we need that this is an angle theta. So these two angles are equal. These two angles which I am going to highlight, this is the angle theta, the same angle this is also. How much you increase the inclined plane angle, so that much the weight mg changes. Now the mg is resolved into component. This is mg cos theta. Yeah, yet here you remember vectors. A vector is resolved into two components. One is horizontal component and vertical component. So theta is the angle made with the horizontal, that's why it's mg cos theta. And another angle which is equal to mg sin theta. Since the object is at rest, so sum of the forces should be equal. Now normal action force N equal to mg cos theta, and there is one more force which I do not represent right now at here. This force which is acting in the backward direction, that is Fs max, limiting friction. Now if the normal action force equals mg cos theta, now Fs max which equal to mg sin theta. So from this we got an expression for tan theta which equal to mu suffix s, coefficient of static friction. So here theta is we defined as angle of repose. So it depends upon the angle of repose. If the angle of repose changes, the block motion changes from the rest to motion. So instead of the applying external force for the inclined planes, so we can change the angle, we can tilt the angle, so that angle just causes to slide the block.